And it's time for one of my favorites, and that is the ratio test. We could try to use the root test, but the thing is, if you do the root test, you need to take the nth root, which for the denominator is going to be great because the nth root of 100 to the n is just n. But then the problem is, what's the nth root of n factorial? Since I don't know, I'm not going to use the root test. So use the ratio test, which basically says take the limit as n goes to infinity, substitute n plus 1 in for n, that is the numerator. For the denominator, you just use the function with n. All right, so for this one, it's going to look like take the limit as n goes to infinity, then make a big fraction, use n plus 1 instead of n. There's the numerator, and for the denominator, it will just have the original function n factorial and 100 raised to the n. And then, of course, when you divide two fractions, you invert and multiply by the bottom fraction. So the top one can stay the same, n plus 1 factorial, and then 100 to the n plus 1, and then multiply by the reciprocal. So this one is going to become 100 to the n, and then n factorial on the bottom. The next thing I'm going to do is factor. So suppose you have something like 7 plus 1 factorial. So that means 8 factorial, which means 8 times 7 times 6, etc., until you get down to 1. So what I could do is rewrite this part as 7 factorial, and then I've factored off the 8. So the original number was 7 plus 1, or in other words 8, so I factored that off, and the rest was factorial. So that's what I'm going to do right here. So take the limit as n goes to infinity, factor off the n plus 1, and then it will leave n factorial. Then I'm also going to factor this 100 to the n plus 1. So if I factor out 100, it's going to take care of that plus 1 part, and it's going to leave 100 to the n. And then just recopy the second fraction, and then get you a red pen so that you can cancel. So the 100 to the n and 100 to the n are gone. Y también los dos. So all that's left is the n plus 1 on the top and 100. And since n is going to infinity, we end up with the limit. Let me just show all of my steps. We end up with infinity on the top divided by 100, and infinity divided by 100 is infinity. So that's basically saying when you, okay, for one thing, that means it diverges. So the answer is diverge. Diverge. Okay, so we're actually done. But what that's basically saying is when you compare the n factorial function to the 100 to the n, which is more powerful? And because this diverges, that means the top is more powerful, so n factorial is the winner.